Hello, these are the notes for Functions and Inverses Day 2. You should have a printout to follow along, or if you're watching from home, there's a PDF file with the video on that page on Canvas that you can open up and print out, or just take the notes as we go. Um, so today we're looking at, well, yesterday we looked at how we do an inverse from a table, right? With just switching the table around, the x and the y. Or what do we look at when we have a graph to find the inverse and going from the y and then reading the x value. But today we're going to talk about how do we do the inverse if it's in equation form. Well, first, here's a quick warm up. I said pause here, do the warm up real quick, and then come back and we'll talk about what we talked about yesterday with the one-to-one function. All right, hopefully you've had a chance to look at these and remember which of the following graphs are one-to-one. It's not just a multiple choice, but any ones. So if it passes the horizontal, well, first, the vertical line test means that it's a function. Horizontal line test, which if you go side to side, does it pass through just one point? Vertical line passes through just one point every time. Horizontal line does the same thing. So the regular one is a function. The inverse is a function for the horizontal line test. So this is a one-to-one function because both are functions. Same thing here. You have a function because it passes the vertical line test, but it does not pass the horizontal line test. A horizontal line will go to two places. So the inverse is not a function. Therefore, this is not a one-to-one function. Vertical line test passes. Horizontal line test, it passes. So this one-to-one. Horizontal or vertical line test, this passes. Horizontal line test, no. And even like here, still goes through 2 points. So you can go through 4 points if you want, but that is not one-to-one. So these two also have their inverse is a function. This one, the inverse, is a function. All right. So today we're just going to focus on linear functions, and as long as it's not like every linear equation is a function, whether it's rising, falling. The only one that's not is if it would be a vertical line itself. That's not a function. So the inverse of every linear function is also a function. They're one-to-one unless it was a horizontal line, but we won't have to deal with any of those. We're just looking at regular linear equations. There are 3 steps to follow. So you're going to switch around your x and your y, change the x to y and change the y to x. Or if it has an f of x, then you'll just change that to x. You're then going to solve the equation for y. I start by reflecting the entire, which means just flipping around the entire equation, and then change that y to your inverse since it's a function. So let's go through some examples of what I'm talking about. So here we have y equals 3x plus 4. So what it's saying is, first thing, you are going to switch this to x equals 3y plus 4. And since I'm solving for y, I'm going to flip this entire equation. 3y plus 4 equals x. And now I want to get rid of everything over here except for that y. It's just like solving an equation. I'm going to subtract 4 from both sides, or I'm just going to, because there's nothing to subtract 4 from really, you're just moving the positive 4 over there. That would be 3y equals x minus 4. So if it's plus 4 on one side, when you take it to the other side of the equation, it'll become minus 4. If it's minus 4 here, move it, it becomes plus 4. The only other thing to get the y alone is you need to divide out the 3. And just make sure you're dividing the whole thing that's on the right by 3. So we end up with y equals x minus 4 over 3. In the last step, once you solve for y, you can now write it as the inverse function would be x minus 4 divided by 3. That's it. So again, when you see a U try, go ahead and pause this, try this one, and then restart it. So hopefully you've paused and you're restarted. So you'd switch, remember, f of x and y are the same thing. So this would become x equals 5y minus 1, or 5y minus 1 equals x. So first I'm going to take the negative 1 to the other side. So 5y equals x. Negative 1 on one side becomes plus 1 on the other. Then I need to divide out that 5. Divide the 5. So y equals x plus 1 over 5, or the inverse function x equals x plus 1 over 5. So this is your basic mx plus b, y equals mx plus b function, but linear functions come in a lot of different ways. So let's look at another one you might encounter. Oh, so this is just has the negative in front of it. So same thing. This would become x equals negative 2y plus 7. Switch your x and y. I'm going to switch the equations. Negative 2y plus 7 equals x. I'm going to move that 7. So it'd be negative 2y equals x minus 7. Plus 7 becomes minus 7. And then divide everything by negative 2. So y equals, the big thing here is that you usually won't see a negative 2 in the denominator. They would probably put it out front and make it negative x minus 7 over 2, which would leave f of x equals negative x minus 7 over 2. Now there's another, if they don't put the solution's not the negative out front, they might distribute that negative into the numerator, which would look like negative x, and then the negative to the negative 7 would be plus 7 over positive 2. That would also be the same thing as having the negative out front of the fraction. So be careful in how it's presented. But again, here's a U try, so pause, try that one, and then restart the video. All right, hopefully you paused. So this one would be x equals negative 4y minus 8. So negative 4y minus 8 would equal x. Bring the negative 8 over, so add the 8, so negative 4y equals x plus 8, and then divide by negative 4. So y equals, since you won't have the negative in the denominator, they could move it up here, but that negative, if it's moved to the top, will change, just like it did here, it'll change the sign. So it'll be negative x minus 8 over 4. So you could write the inverse as negative x minus 8 over 4. If you left it with the negative out front, you could do that, which would just be putting the negative. So it'd be negative, then the fraction x plus 8 over 4. All right. So same thing, but now you have a fraction for your slope, right? So it's still going to be the same steps. Step one, I'm going to change. So this would be x equals -2 over 3y plus 5. Do the reflection, -2 over 3y plus 5 equals x. Then you can subtract the 5, so -2 over 3y would equal x plus 5 on this side becomes -5. And now to get rid of this fraction, you can just multiply the reciprocal on the other side. When you have a fraction, you could say that y equals, the reciprocal would be -3 over 2 x minus 5. You're multiplying it times that whole thing. Now, this might be an answer. They could distribute that, and if it's distributed, it would be a -3 over 2x. Negative times negative would be plus. And remember, if you're multiplying a fraction times a whole number, you can put it over 1, and that would be 15. 3 times 5, 15, over 2 times 1 is 2. So it might be written like that. And then you can change those to your inverse symbol. So either one of those might come out. I'd accept either answer, but when you're taking a multiple choice test, you got to take the answer they gave you. All right, so pause and do the you try number 3, follow the steps. When there's a fraction, use the multiply the reciprocal. All right, so first thing, switch the x's and the y's. So x equals 1/2 y minus 3. Reflect the whole equation. 1/2 y minus 3 equals x. Bring the 3 over. The minus 3 is going to become plus 3. 1/2 y equals x plus 3. And then multiply the reciprocal. So y equals, and the reciprocal of 1 over 2 is 2 over 1, which is just 2x plus 3. So if that answer is not right, then you could distribute and get 2x plus 6 for either of them. And then remember, you can change it to the inverse or -1, the inverse function instead of y. All right. All right, so example 4 is still linear equation. This time it's before it's been distributed. So we have a couple choices here. Let's look at if we don't want to distribute, you could, so you can do the first step, switch the x and the y, so 7y minus 4. Switch it around, so it'd be 7 times y minus 4 equals x. You could do the divide first since it's on the outside of the parentheses. So if you have these parentheses, you could divide out the 7 first, or what would be the reciprocal of the 7 to the other side. So you'd end up with y minus 4 equals, so again, 7 would be 7 over 1, so that would be 1/7 x. You just do the reciprocal. And then you can move the minus 4 over, and minus 4 would become plus 4 on the other side. So y equals 1/7 x plus 4. Now, If you distribute, that becomes a whole different problem. You'd get x equals 7y minus 28, right? The 7 times the 4. Switch it around. 7y minus 28 equals x. Then you would take the 28 over. 7y equals x plus 28. And then divide both sides by 7. So you end up with x plus 28 over 7. Now these two are the same. I think this is easier, but this one is also correct. So in the 7, the 28 divided by 7, that's that 4. So if you're like, how are those two the same? Well, 1, there's a 1 here in front of the x. 1 over 7 is your 1/7. 28 over 7 is your 4. So this is just written as one fraction. This is the fraction in the front. So you try number 4. Try it with this method and the reciprocal. It'll make a lot more sense than trying to distribute that. So pause and try that. Okay, so hopefully you have unpaused and you have what you hope is the answer. So you're going to switch x with y, negative 3/4, y plus 5. Rewrite it, negative 3 over 4 y plus 5 equals x. Now, just like we did the 7, you can do the reciprocal to the other side. So you'd end up with y plus 5 equals negative 4 over 3x. So just when you move a multiply to the other side, you can just do the reciprocal. Now you just need to move the plus 5 over the other side, so it'll become minus 5. It'll be y equals negative 4 thirds x minus 5. And again, once you get to that, you can change this to the inverse negative 1 of x. Okay, so we've seen some that ended up in fraction form, so let's look at if they begin in this fraction form. So the whole thing is a fraction in example 5. And again, first step is to switch your y's and your x's. So it'd be x equals y minus 8 over 3. Reflect it, y minus 8 over 3 equals x. And now you're going to get rid of the denominator first. And the way to get rid of the denominator would be to multiply it to the other side. So the 3 in the denominator will become 3 in the numerator over there. So it'll be y minus 8 equals 3x. And then get rid of that minus 8 by adding it to the other side. Y equals 3x plus 8. Or the inverse function would be 3x plus 8. So again, you have that you try number 5. So pause for a second. Just a little hint if you haven't paused yet, or if you have, that negative will just go with that 7 when you take it to the other side. But try that. All right, so first step would be x equals negative y plus 4 over 7. Switch it, so it'd be negative y plus 4 over 7 equals x. When you bring the 7 over, you bring the negative also. So that would be y plus 4 equals negative 7x. That whole negative, just like when it was negative in the denominator, we brought it to the front. Well, you can put it back in the denominator to bring it over. Now you just have to move the 4 over and subtract it, right? So y equals negative 7x minus 4. Or the inverse would be negative 7x minus 4. That's it. So in example number 6, same thing, you just have more stuff to deal with an expression in the top and the denominator. So again, we will do x equals negative 5y plus 3 over 8, or negative 5y plus 3 over 8 equals x. All right, so to solve that, we're going to multiply that negative 8 to the other side. So 5y plus 3 would equal negative 8x. Just like before, subtract the 3. So 5y equals negative 8x minus 3. And finally, like we did in the very first ones, that can just become a fraction. So y equals negative 8x minus 3 over 5. That. And of course, you can change that to now the inverse function symbol. So again, last one, you try number 6, pause, come back. All right, hopefully you've tried this. So we're going to do x equals 2y minus 5 over 3. Switch the sides, 2y minus 5 over 3 equals x. Get rid of that denominator first by multiplying it up. So 2y minus 5 equals 3x. Now, the subtract the 5 becomes add 5 to the other side. So 2y equals 3x plus 5. And finally, with the 2y, we can just divide everything by 2. So y would equal 3x plus 5 over 2. All right, so that should be the end of it. So there's an assignment. 1.3 day 2 assignment on Canvas. You should have a printout of that, or you can print it out at home, finish it, take a picture and submit it, and we'll talk about it tomorrow. Have a great day.